has the property of 1 to 1, therefore it will have an inverse function. Perfect. Describe in practical terms the meaning of f inverse of 0.25, 0.5, and 0.7. Okay. Allow me to explain by, first I would like to quickly graph it. We're not going to read from my graph. So this is the probability, and this is X number of people. And the graph again, roughly, is something like this. And this is 60, and this is 1. Okay, good. So they want us to find f inverse of 0.25 and explain what it means. So again, we're not reading from my graph, but let's say if I have 30 people in the room, the probability that 2 people share the same birthday, I'm going to say is 0.5, which is 50-50. Again, we're not reading from my graph, I'm just explaining. If, let's say, we have 10 people in the room, the probability that 2 of them share the same birthday is 0.15. They're asking now to find, so for the function f, meaning, according to my example, f of 30 is 0.5. F of 10 is 0.15. But they're asking us something else. They are saying F inverse, how many people does that mean? If the probability is here somewhere 0.25, in other words, how many people, number of people, according to the function, how many people should I have in the room for the probability that 2 of them share the same birthday is 0.25. So for the function x, f of x, for the inverse, f inverse applied to this number will give us back this number. So let's go back and read from the graph. What will it mean? In other words, f inverse of 0.25. And then the same question for 0.5 and the same question for 0.7. Can anyone tell us what f inverse of 0.25 represents? In other words, how many people should be in the room for the probability that 2 of them share the same birthday to be 0.25? Roughly. I know it's difficult to read. 0.25 is somewhere here. What will you say roughly?
Maybe like 14 or 15.
Perfect. So f inverse of 0.25 is 14 or 15 people. Excellent. F inverse of 0.5. F inverse of 0.5. Can anyone try F inverse of 0.5? Can anyone try F inverse of 0.5, please?
25.
Yeah, I would say about 22. Good. Hard to read, I agree. And can anyone give us F inverse of 0.7? F in 28, I would say. Yes.
Sorry, I was reading the wrong thing.
That's fine. Good. Any questions on the inverse function, how to read from a graph, how to calculate the inverse function, how to graph the inverse and the function on the same coordinate system, how to verify that they are inverses of each other? Our test on chapter 2 is next Wednesday, not this Wednesday, next Wednesday. I want to use both sessions, this Wednesday and next Monday, to review for the test, not just one. So I am going to finish now this chapter with 2.8. And please, number one, don't miss Wednesday and Monday, and make sure you are registered for the test already on the 8th. Okay? So I think we need a 2-session review moving forward. So 2.8 is the last section of this chapter. It deals with 3 things: distance, formula, midpoint, formula, and the equation of a circle. Distance formula, midpoint formula, and the equation of a circle. Okay, so let's start with the distance. The distance between 2 points, that's what it means. Here's a point A, here's a point B. This is x1, this is y1, this is x2, this is y2, and this is the line segment connecting A to B. And this is the distance in question. So the distance of segment AB equals, is what we're trying to determine. We're going to be using the Pythagorean theorem. We are going to form a right triangle. This is a 90-degree angle. These are the legs, and this is the hypotenuse. And as you see, this distance is x2 minus x1. x2 minus x1. Can anyone give us this distance? So this was x2 minus x1. What do you think this distance equals to? Which is the same here.
Is it y2 minus y1?
Absolutely, thank you so much. So if you remember the Pythagorean theorem, the longest side, which is the hypotenuse, the longest side squared equals the sum of the squares of the 2 legs. The legs are the ones, the sides that form the 90-degree angle. So it's x2 minus x1 and y2 minus y1. Of course, from here, we will apply the square root to both sides. We will not put plus or minus because it's a distance. Otherwise, I should. And this is the square root. Remember, we cannot simplify the square root if we have a sum of 2 quantities or a difference. So no one can change this. No one can simplify it in any way, shape, or form. This is it. This is the distance formula. So in order to determine the distance between these 2 points, we take the square root from the sum of the squares of the 2 legs. distance formula. Also, something called the midpoint. Midpoint. The point right here in the middle, M. The formula for the midpoint is the sum of the two x values divided by 2, comma, the sum of the two y values divided by 2. And this is the midpoint formula. So now we want to illustrate how to determine these two. Please give me any two ordered pairs you can think of. Any two ordered pairs, please. Please give me any two ordered pairs you want to work with.
4 and 2.
4 and 2 is perfect. Throw in some negative in there.
Okay, -5. Can we do 2 negatives?
It doesn't matter. It's up to you. At least one.
Okay, -6.
And -6. Perfect. Very good. The midpoint is the easiest. And I'm going to start with the midpoint. The sum of these two is -1. The sum of these two is -4. That's all we need to do. Determine the sum of the x values, -1, divided by 2, of course. Determine the sum of the y values, -4, divided by 2. So this part is done. Now I want to determine the distance. For determining the distance, I have to be careful. Not difficult at all, but just careful. I write the formula. The square root of x2 minus x1, everything squared, plus y2 minus y1, everything squared. I label the ordered pairs so I don't make an error. x1, y1, x2, y2. And now careful. x2 minus x1, x2 minus x1, -5 minus 4 is -9. So this piece will be -9 squared. -6, -6 minus 2. This piece will be -8 squared. Remember one thing. This is something squared. It can only be positive. This is the sum. This is something squared. It can only be positive. Do not ever write that the distance is the square root of -57. I don't want to see this, please, please, please. This is definitely carved in stone, a positive number, then plus. Definitely carved in stone, a positive number. So, here's what I write. D equals the square root. That's why I wrote it like this, so I don't make a mistake. -9 squared is 81. -9 times -9, and then plus. -8 squared is 64. So please do not ever write any negative numbers under the square root for the distance. So then I add them up. You cannot, remember, it's a sum. You cannot separate the radical if it's a sum underneath or a difference. So I have 100, the square root of 125. Yes, you can change this into 25 times 5. That would be nice, as we did before, a month ago. So the distance is this. Any questions on how to determine, how to evaluate or calculate the distance between 2 points, and how to find the midpoint? the point that divides the segment into two equal pieces. That's the midpoint. Any questions on how to determine the distance and the midpoint? Do we need another example to find the distance and the midpoint?
Can we do one more?
Yes. Can anyone pick two ordered pairs, please? Can anyone give us two ordered pairs, or I will make them up? -2, 3, 4, 6. Label them. Good. The midpoint is the easiest. Add them up. I get 2. Divide by 2. Add them up. I get 9. Divide by 2. Done. Now that this is a different story, I have to be careful. Write the formula. Right underneath. Careful. 4 minus -2. But that's 4 plus 2, which is 6. So 6 squared, this will be 36. 6 minus 3 is 3. And 3 squared will be 9. I got my numbers. So I have the square root of 36 plus 9, which is the square root of 45. 9 times 5. So I can write 3, the square root of 5. Any questions? Okay, so is this good enough? Are these examples okay?
Yes, thank you.
Perfect. So we talked about the distance formula, we talked about the midpoint formula, and this is the final item on the list for chapter 2. Okay, last one. The equation of the circle. Okay, what is a circle? The circle has a center. Here it is. Has a radius. The center, we normally denote the coordinates of the center with a comma b. It's not important, but that's how we like to present the center of a circle. And this equation, as you see, it's not going to be a function. By the vertical line test, it's not a function. So any point here, let's say point A, coordinates x comma y. And C again coordinates a comma b. And this distance from C to A is the same with the radius. So remember what we wrote before. We wrote that the distance squared equals x2 minus x1 squared plus y2 minus y1 squared. This is what we wrote a few minutes ago. Let me go back. We wrote that d squared equals x2 minus x1 squared plus y2 minus y1 squared, and then we apply the square root. There is no need for the square root for now. D squared equals the sum of these two. Well, all I have to do to this equation is plug in this. So this is my x1, y1, and this is my x2, y2. Just plug them in, and I will get the equation of the circle. So from the equation, from the distance formula, all I have to do is I'm going to use x comma y as x1, as x2, y2, and I'm going to use c I'm going to use C as A comma B as X1, Y1. That's all I'm doing. I'm writing the distance formula, knowing now that the distance is basically the radius squared. That's what the distance is between point A, any point on the circle, and the center. So this piece becomes R squared. What is this piece? X minus, so X2 minus X1, X minus A, everything squared, plus. What is this piece? Y minus B. This is the equation of the circle. What did I do? Nothing. I based the whole thing on the difference, based the whole thing on the distance formula, labeling the central of the circle as A comma B, and any point on the circle as X comma Y. And I replace these in the distance formula. And this is the equation of the circle, where of course A and B are the central, the coordinates of the center. Equation of the circle. There is an L in here. That's it. So here's our first question. I know we have 6 minutes. I'll finish in 6 minutes, I promise. So if we are given this equation, x plus 1 squared plus y minus 4 squared equals 25. So this is given to us. This is given. I'm asking you, is this the equation of a circle? If you say yes, then I would like us to determine the coordinates of the center and the radius. All you have to do is compare this equation to this equation. Do they look similar? Do I have something with x squared plus something with y squared equals some number?
Yes.
Perfect. So this must be the equation of a circle. Let's start with the easy part. Can you identify the radius? Anyone?
5 squared.
Say it again.
5 squared.
So the radius is just 5. Correct. Just 5. Because when I square it, I get 25. Perfect. Can anyone carefully identify the center, the coordinates of the center? When you compare these two, you can determine A carefully. When you compare these two, you can determine B carefully. Can anyone tell us what A would be and what B will be?
Is it 1 comma negative 4?
So careful. Y minus 4, this is the B. But careful here. What is A? I have to rewrite this as x minus, so I can get x plus 1. What should I have in here to get x plus 1?
-1.
Yes. So this is how I read the A. So A is -1 and B is 4. Good. Final step, and I stop. Graph it. Graph the circle. Very easy. I plot the center. That's my first step. -1 comma 4. 1, 2, 3, 4. And I go east, west, north, south, 5 units away. North, 1, 2, 3, 4, 5. East, 1, 2, 3, 4, 5. South, west, 1, 2, 3, 4, 5. Connect. This equation is x plus 1 squared plus y minus 4 squared equals 25. We started by plotting the center, which is -1, 4. And then in all directions, east, west, north, south, 5 units away. Why 5? Because it's the radius. So this distance has to be 5, this distance has to be 5, this distance has to be 5, this has to be 5, everything all around has to be 5. All points on the circle have to be exactly 5 units away from the center.